Go. Hi. Exam 2 review. I know. No one wants it. You don't want it, I don't want it, and it's still somehow here. So, what is this all about? Techniques of integration. So we're talking chapter 8 plus those few concepts from chapter 9. So chapters 8 plus 9. Talking about 10 problems. Stakes on this exam are higher because it's the higher percentage in terms of the grade. I hope you already did the post-test for chapter 8 to practice and see where the holes are so you can fill them by Monday. The concepts that you need to know for this are not just, integration by parts. No, it starts with basic integral, obviously, because you need to know basic integral and then plus c, right? It's going to be very important. So even though these sections are in Calculus 1, they're extremely important for your success on this exam. So I'm going to list them on this review. Number 1, basic integrals. Now this is under 8.1, but technically this is 4.9 and 5.2. Number 2, U sub. This is 5.5 in Calc 1. You cannot survive any integration exam from this point on, Calc 3 differential equations, without U sub. It's the most important and most frequent integration technique of all time because it's backwards chain rule. So it must be featured at least 2 or 3 times on this exam, because some of these procedures are simply changing your trig. Let's say you have, secant squared tangent to the 4th. That's going to end up being U sub. You will have trig identities, and then U sub will end the problem. So U sub is extremely important. I understand it was Calc 1, but it has to be on the list. Number 3, by parts, finally. Number 4, trig integrals, which is primarily you are going to worry about those forms and sine and cosine. So does it have at least one odd exponent, or they're both even? If it's both even, then that's the worst case scenario. If one is odd or both are odd, then that was very easy and nice. With the U sub you can solve it quickly. Secant tangent pair and the cosecant cotangent pair working the same way, just with minus signs all over the place. Now, number 5, trig sub. You have the triangle and you write out all of those sides and substitute everything, and it ends up being a trig integral, obviously. Solve it and unwrap it. 6, partial fraction. Usually I give 2 problems. 2 or 3 variable problem. Solve all the way. 6 plus variable problem. Setup only. So usually I give 2 problems on this one. Partial fraction decomposition will be important for inverse Laplace transforms. You see, for inverse Laplace transforms, if you are learning it to know it ins and out, you will need by parts to do the Laplace transform. But then Laplace transform, there is a table of Laplace transforms, and you actually don't have to use integration by parts because you can look at the table and you can memorize some of those and you can just, be done with it. But to do the inverse Laplace transform, which is equivalent to when you do the u sub and you have to go back to x, right? So for inverse Laplace transform, it's pretty much the same deal, right? You go to your original time domain. You will have the table of inverse Laplace transforms, but it will be useless in some cases because you will not recognize your problem. You will not be able to match it to anything on a table because you need to do the partial fraction decomposition first. So partial fraction decomposition will be used in differential equations to break apart. And you also saw partial fraction decomposition and telescoping series we did earlier, right? So it's not a technique that is just, it's annoying and let's practice for a test. It's something that you use over and over again. So partial fraction decomposition is important and as you can see featured over there. Number 7, remember that we are skipping the other integration techniques, which is the one that uses the integration table, which I can give you for the test, obviously. So we're skipping that one. But we can do the numerical integration. That one has the 3, right? There is a midpoint, trapezoid, and Simpson. Number 8, improper integrals. Type 1, type 2. Most likely both will show up. Type 2 is the evil one, right? Number 9 and number 10 are differential equations. Number 9 will take separation of variables, and 10 checking solutions, which is where you differentiate and plug in and so on. So this is the exam. There's a lot of room over here to combine these concepts together. For instance, separation of variables. If I really want to write a terrible example of that, I can have a separation of variables so that when you separate your variables, on one side you have to do integration by parts, on the other side partial fraction decomposition. Right? So, I'm not going to do that, but I'm saying, right? Probably I can pack all of this in 2 problems. So, basic integrals, they are always the end of u sub, right? A lot of trig integrals end with u sub. By parts is kind of its own technique. Trig sub obviously always ends up with the trig integrals, and trig integrals most of the time end up with the u sub, and each u sub ends up with a basic integral, right? So technically, anytime there is a trig sub problem, it triggers 1, 2, 3, 4. That's usually how it goes. Now you don't consider these ones as methods because this is what you're dragging from Calc 1, but if you have a trig sub question that ends up being a trig integral that has to use u sub, then yeah. Partial fraction decomposition I already explained. We did a whole bunch of problems, but partial fraction decomposition is important. Numerical methods. In the past I did ask a regular problem and then a very simple problem, which would cover 2 out of 3. In some exams I said use your favorite method. So it will be something with the numerical, but I never go more than 4 rectangles, right? So you are not sitting here for 12 hours computing, you know. And improper integrals are type 2 is the scary part, because first you have to know that there is an asymptote, there's some kind of problem in the domain from A to B. And then you also need to be able to integrate. So every problem, right, 1 through 6, which is all integration, every problem 1 through 6 could be improper. Every problem you ever solved in Calc 1 could be improper. So these are the things that you have to be very, very careful from now on. We talked about it last time. I said that up to this section, we had to be careful as instructors not to give you a problem that you can't solve. So the difference between integral of dx of x plus 5, the integral dx of x plus 5. This one is going 0 to 1. This one is going, actually let's go negative 10 to 10 and 0 to 10. There is a huge difference between these two. To Calc 1s, no difference at all. They're going to compute, they're going to get values, they're going to get numbers, and right, because they don't know improper integrals. But you know which one of these two is the terrifying one, and which one is the one that is Calc 1 you just go and solve, right? It's a big difference. Which one is the problem? The left one, negative 10. Because negative 10 to 10 includes which number that it's very bad? Negative 5. And that's the one at negative 5 where this goes to infinity, and this is divergent. So if this ends up being your model for energy stored in a battery, you just created a bomb, right? Those are the things that you have to understand as engineers. So they look the same, and to untrained eye, with right, not paying attention to the vertical asymptote at negative 5, and that being included in that interval over there, can create big problems. So are you going to integrate 1 over x in Calc 1? Sure, but you're going to integrate it from, let's say, 1 to 3. You're not going to integrate from negative 1 to 3, because negative 1 to 3 goes through 0, and 0 is the vertical asymptote for 1 over x, and then we have the same problem as right there. So over here, we'll just label it as a joke, right? Because it's immediately ln x plus 5, computed from 0 to 10, and you're done. So it's called a joke. It's a basic Calc 1 U sub. And if you did your homework for partial fraction decomposition, probably 90 integrals worked out in this region, right? Where you immediately recognize that a number divided by a linear function is always ln of the denominator. So that's a joke. This one over here is the evil one, because there is a vertical asymptote at x equals negative 5. This is the one that breaks into two integrals. You have to go from negative 10 to negative 5, dx x plus 5, plus negative 5 to positive 10, dx x plus 5. So we have to start the problem this way to break it at the bad point, because the bad point of -5 is going to get the limits. So we start with the limit b goes to -5 of integral dx over x plus 5, and you have -10 to b, plus another limit b goes to -5, no, b, sorry, a goes to -5, and now you have a to 10 of dx over x plus 5. And now you see that when you plug in the values, I mean, you integrate now, sorry, first integrate, b goes to -5. When you integrate here, you get the ln of x plus 5. ln of x plus 5, and that's calculated from -10 to b. And on the other end, you have the limit a goes to -5. Again, ln, same x plus 5, but this one goes from a to 10. What is happening when I plug in -5? I get ln of 0. And ln of 0 is -infinity, and the whole thing explodes. It diverges, right? So, as soon as I have this, I have limit b goes to -5, ln of b plus 5, minus, this one is ln of -10 plus 5 is -5, so just ln 5, plus ln, no, limit first. Limit a goes to -5 of ln of 10, no, lies, 15, ln 15 minus ln of a plus 5. We don't need absolute values here, we can do parentheses, because a is, no, need absolute values, a is negative. This term over here goes to -infinity, and that's what makes it divergent. It's scary stuff. So, your job on every exam from this point in time till you're done with your degree, you have to check your definite integrals for type 2. Because if the vertical asymptote sneaks in and you don't see it, you are going to get a garbage answer that has nothing to do with the reality, what is the solution for, right? You can solve that problem incorrectly and see what you get. Maybe 0, I don't know. Did you get a 0 here? Yeah, because it will be ln of, no, it will be ln 5, it will be ln 5 minus ln 15. That's what, if you do the problem incorrectly, you will get ln 5 minus ln 15. That can be compressed into ln of 1/3, and then you can make that into a decimal. And obviously that's nothing close to what it actually is, which is infinity. So two problems which look the same apart from, right, the asymptote that it's included. So improper integrals are tricky ones. Do you have any questions that you would like me to work out right now? Great thing you all came prepared with questions and things, knowing that the review is today, or it was like way too early to start prepping for the exam. I'm not sure. Or the best one, we just know everything and there's no reason for us to talk. That's the one that I like to think that's you simply just know. No questions? All right.